Question number 8. A chord CD of a circle where center O is bisected at P by diameter AB. A chord CD. So this is the chord CD. This is the chord CD whose center is O, bisected at point P having diameter AB. This is a circle whose diameter is AB, and here is the chord CD which is bisected at point P by the center O. So this is the diagram. Okay, now OA is equal to OB is equal to 15 centimeter. OA is equal to OB which is 15 centimeter. OA is equal to OB which is 15 centimeter, and it is also the radius of circle. Clearly AB is diameter and it is diameter and it is 30 centimeter. So the radius B AB, radius B OB is equal to OE is equal to 30 by 2 which is 15 centimeter. OP is 9 centimeter. The perpendicular distance from the center of the circle to the chord is 9 centimeter. Calculate CD, length of chord, AD, this one, and CB, this one. Okay, we have to calculate. So first of all, join BD. I have to join BD. Now BP, this is BP, is equal to OB minus OP. This OB is 15, which is already given, and OP is 9. So if I have to find PB, then it is OB minus OP. 15 minus 9, 6 centimeter. So here it is 6 centimeter. Now in right angle triangle BPD, this one triangle, in right angle triangle BPD, this is BD. BD square is equal to BP square plus of PD square. I can say that hypotenuse square is equal to perpendicular square plus of base square. BP is 6, base is 12, so 6 square 6, 36, 144 is that 180. That is 180. So clearly I calculated BD by Pythagoras theorem and it is 180. Now I have to move in triangle ADB. ADB. This is the triangle ADB. Clearly AD is the perpendicular. Okay, this is the perpendicular. So I am going to apply Pythagoras in that diagram. ADB, which is right angled at that triangle ADB, which is right angle at that point. Okay, angle in semicircle is at right angle. Angle in the semicircle is a right angle. This is a theorem. So by applying Pythagoras there, this is the hypotenuse, AB is the hypotenuse, AD is perpendicular, and BD is base. So I have AB square is equal to AD square plus BD square. AB square is equal to AD square plus of BD square. AB as it is. I am going to shift BD there, is equal to AD square. The value of AB is 30 square. The value of BD is 180. Now I am going to subtract that. The value of AB, it is the diameter of the circle also, and now it acts as a hypotenuse for the triangle ABD. So the value of hypotenuse is clearly 30, and the value of BD, which I calculated there, is 120, the value of BD square, and I have to calculate AD. So I'm going to apply the Pythagoras theorem there, that is 30 square minus 180 is equal to AD. 30 times 30 is 900 minus 180, AD square as it is. 900 minus 180 is 720, and here I have AD square. I'm going to shift that on that side. Then I have the value of 720, which is 26.83 centimeter AD. So this was the question 8th, which is quite easy. Just you have to understood the diagram and the given parameters. Okay, so let's move on to the question number 9th. This is the question number 9th. A straight line is drawn cutting two equal circles and passing through the midpoint. A straight line, so this is straight line, O dash, is drawn cutting two equal circles. So this circle is equal to this circle and passes through the midpoint M. Passes through the midpoint M of the line joining their centers O and O dash. So this, consider this circle, its straight point is, its center is O and its center is O. Let's O dash. Okay, I'm going to join these centers, and there is a straight line which cuts this line at point M. Okay, I have to prove the codes AB, the code AB and CD, this is CD, which are intercepted by the two circles are equal. This code and this code are intercepted by the two circles are equal. So clearly I have to prove that this AB is equal to CD, this one. Okay, this question is also quite easy, just pay attention. Okay, given what I have given, I have given a straight line AD, a straight line AD, a straight line AD intersect two circles of equal radius at A, B, C, D. I have a straight line AD and it intersect the two circles. These two circles are equal, and this straight line intersects these two circles at point A, B, C and D. This straight line intersect the circles. Line intersect the circle. So we have to look at the points which are in connection with the line as well as circle A, B, C, D. Clear? Now, the line joining the O and O dash, the line joining the center O and O dash intersect AD at M, and M is the midpoint O dash. The line joining the centers O and O dash intersects AD at M, and M is the midpoint of O and O dash. I have O and O dash, and M is the midpoint of this. Okay, the line joining the centers O and O dash, this line joins the center and it is intercepted by the another line at point M. To prove AB is equal to CD, from construction I will draw OP perpendicular on AB and OD dash Q perpendicular on CD. I have drawn OP perpendicular on AB and O dash Q perpendicular on CD. Okay, and I know that in triangle OMP and triangle OM dash Q, this is triangle OMP, OMP, and this triangle O dash MQ. I'm going to congruent these two triangles. So first of all, this angle and this angle are vertically opposite angles. If I have these types of angles, then I am going to do that. This is known as, these angles are known as vertically opposite angles. Vertical opposite angles. Okay, angles which are in front of each other. So these are known as vertically opposite angles. They always form X. Okay, so these are the vertical opposite angles. Now, angle OPM, OPM and angle O dash QC, angle OPM and angle O dash QC both are 90 degree because these are perpendicular on these sides. If O dash Q is perpendicular on CD, that means it is 90 degree. Similarly, if OP is perpendicular on OB, then it is also 90 degree. Okay. So first of all, I have vertical opposite angles, then each 90 degree. Now clearly, OM is equal to O dash M. OM is equal to OM dash because M is the midpoint of OO dash. M is the midpoint of OO dash. That's why MO is equal to O dash M. So by side, angle side, criterion of congruency, by angle side criterion of congruency, both these triangles are congruent. Both these triangles are congruent. Okay, by angle side criterion, both these triangles are congruent. Number one is vertical opposite angles, number two each 90 degree, and side are equal because M is the midpoint of these two points. So by CPCT, if two triangles are congruent, then the corresponding pair of corresponding triangles criteria, we have OP is equal to OQ. I have already proved these two triangles as congruent triangles. That's why OP is equal to OQ by CPCT. OP is equal to O dash Q by CPCT. We know that two chords of circle are of equal circles, two chords of a circle, two chords of a circle or two chords of equal circle which are equidistant from the center, which are at the equidistance from the center are equal, that is AB is equal to CD. First of all, I have proven that both the triangles are congruent, and by CPCT I have written OP is equal to O dash Q, and I know that two chords of a circle of equal circles which are equidistant from the center are equal. Therefore, AB is equal to CD. Okay, two chords of a circle, or two chords which are at equidistance from the center are equal, so AB is equal to CD. So this is the question number 9th, which is completed.